Hello everyone, my name is Rahul Shenoy from Samsung Display America Lab, and today I will be presenting our work on Gradient-Free Classifier Guidance, or what we call GFCG, for diffusion model sampling. Diffusion models have recently achieved remarkable results in image generation. However, guiding these models to generate images that accurately match a desired class or prompt remains challenging. As shown on the left side of the poster, existing diffusion guidance methods often face a fundamental trade-off between fidelity and efficiency. For example, classifier guidance can improve class alignment, but it requires computing classifier gradients during sampling, which is computationally expensive. On the other hand, classifier-free guidance, or CFG, avoids gradients and is efficient, but often compromises class alignment. More recent methods such as auto guidance or ATG can improve diversity and overall image quality, but they do not explicitly use classifier feedback, which can limit class precision. This raises a key question. Can we leverage a classifier to improve class alignment without computing gradients or sacrificing diversity? To address this problem, we introduce Gradient-Free Classifier Guidance, or GFCG. The main idea is simple but powerful. Instead of computing gradients from a classifier, we use a pre-trained classifier only in inference mode to guide the diffusion sampling process. At selected denoising steps, the model first predicts the estimated clean image, or x0 hat, from the noisy sample. Then we evaluate the classifier to estimate the probability of the desired class. Based on this classifier feedback, GFCG introduces two key innovations. The first innovation is adaptive reference class selection. Instead of using a fixed unconditional reference sample like in classifier-free guidance, we dynamically select a reference class that represents the most confusing alternative. Specifically, if the desired class is not the highest probability prediction, we push the sample away from the most likely incorrect class. If the desired class is already the highest probability, we instead push away from the second most likely class. This adaptive mechanism reduces class confusion during diffusion sampling process. The second innovation is the adaptive guidance scaling. Here, the strength of the guidance is adjusted dynamically based on the classifier confidence. If the classifier is uncertain about the desired class, the guidance becomes stronger to correct the sample. If the classifier is already confident, the guidance becomes weaker to avoid overcorrection and preserve diversity. Together, these two mechanisms allow the diffusion model to improve class alignment while remaining computationally efficient. Next, let's look at the results. On the right side of the poster, we evaluate GFCG on class conditional image generation using ImageNet at 512 by 512 resolution. Using the EDM2 diffusion models, GFCG significantly improves class precision compared to existing gradient-free guidance methods. For example, on the EDM2S model, autoguidance achieves 90% precision, while GFCG improves this to 95.2%. Similarly, on the larger EDM2XXL model, precision increases from 89.9% to 96%. Importantly, GFCG is also complementary to other guidance methods. When we combine GFCG with auto guidance, using mixed guidance, we achieve state-of-the-art performance, reaching an FDDyno V2 score of 23.39 while maintaining high precision of 94%. We also evaluate GFCG on text-to-image generation using stable diffusion 1.5 with a challenging fine-grained bird species dataset. In this task, GFCG improves precision from 27.3% with classifier-free guidance to over 32%, demonstrating strong improvements in the fine-grained class alignment. This is particularly important for the long-tailed classes where diffusion models often struggle. Finally, our ablation studies show that the adaptive reference class mechanism provides the largest improvement in class precision, while adaptive scaling helps stabilize the trade-off between fidelity and diversity. To conclude, this work introduces gradient-free classifier guidance, a new approach that leverages a pre-trained classifier without computing gradients. GFCG improves class alignment maintains diversity, and integrates seamlessly with existing guidance methods. When combined with auto guidance, it achieves state-of-the-art performance on ImageNet diffusion sampling. Thank you for your attention, and please feel free to reach out if you have any questions. Thank you.